Hello everyone, welcome to Pinstein Classes. So today we are going to calculate moment of inertia due to continuous mass system. So for continuous mass system, unlike the discrete one, for discrete one we had the formula sigma m times r square. Instead of this, for continuous mass system, we have the formula I is equals to integration m r, or we can say m dx dr square. So what is all these things? We will discuss part by part, and the most basic thing is we should familiar with some basic integration to calculate moment of inertia due to continuous mass system. Alright, so first case is, let us calculate moment of inertia due to a thin rod. Suppose we have a rod and the rod is rotating about this axis like this. Suppose the length of the rod is given L. So for this rod we have to calculate the moment of inertia. Alright, so first of all let us calculate that one. So for that we will consider an elementary mass of dm of width dx, which is at a distance x from the axis of rotation. Suppose this rod has linear mass density lambda. So lambda is equals to dm upon dx, and suppose this rod has a total length, a total mass of m. So it will be equal to m upon L. Now for the smaller mass will become m times m upon L into dx. Alright, so in our formula, let us, in our formula this is not dr, this is m times r square. Alright, or we can replace this variable according to our need. So let us put this smaller mass. Okay, so there will be infinite number of masses in this length for that rod, right? So let us use the formula of integration to calculate moment of inertia. So the smaller mass will be m upon L time dx times x square, and the limit will become from 0 to L. 0 to L. So this will become m and capital L will be constant, so it came out of our integration, and this will become x square times dx. So m upon L, x cube upon 3, 0 to L, and this will become ml times L cube upon 3, and L and L will be cancelled out. This will become ml square upon 3. So the moment of inertia for a rod about its one end is ml square upon 3. Now sometimes what they do is they change the axis of rotation. Instead of giving the axis of rotation at the end, sometimes they give the axis of rotation in the middle. So to deal with these cases, we have a special formula to shift this moment of inertia, and that is called a special theorem, and that is called parallel axis theorem. What does it say is that if we know the moment of inertia from the one axis, we can shift to the other axis, like I new is equals to I old plus m is the mass of that object times the distance which we want to, about the distance for about which we are shifting the moment of inertia. So suppose we are shifting the moment of inertia from the one end to the middle. So this distance will become L upon 2. And now the new moment of inertia will become old one. About the one end we know that this is mls square upon 3 plus m times, and the distance d value will be L upon 2 because we are shifting the moment of inertia by amount L upon 2. So L upon 2 is square. So this will become mls square upon 3 plus mls square upon 4. If we further simplify it, it will become mls square upon 12. So moment of inertia about the middle axis will become mls square upon 12. So this is all for today. In the upcoming lectures, we will only calculate moment of inertia for different cases. So that's all for today. Hope we will meet in the next class.